Hi all. Today we're going to talk about synthetic division, remainder theorem, factor theorem, and rational root theorem. They all go hand in hand. We're going to start with synthetic division first because it's the basis for everything. So for synthetic division, it's a way to divide polynomials, and it only works for dividing polynomials by a linear factor of the form x minus c. So if, for example, I give you 5x to the fourth minus 3x cubed plus 6x squared minus x plus 12 divided by x minus 4. Excuse me. This is going to be your divisor. Okay. And we're going to set that divisor equal to 0. So over here, I'm going to say, okay, x minus 4 is equal to 0. So x is 4. That is what we are going to place on this shelf over here on this other part. And then we are going to write all the coefficients of this long polynomial that we are dividing by x plus 4 in descending order. If there happens to be a exponent missing or a term missing, then you will put a 0 in its place. In this case, we go from 4 to 3 to 2 to 1 to none. So none are missing, so I don't need a placeholder. But if, for example, the x cubed term was missing, I would do 5, 0, then pick up at 6, -1, and 12. So this right here is going to be the coefficients, including their signs. So this is the coefficients in descending order. Of each term in descending order. And this is the divisor equal to 0. And then underneath those coefficients, we draw a line. And now we're going to actually do the process. So the first thing we're going to do is bring down that first term. That is the only one you don't do anything to but bring down. After that, you take what's on the shelf and you multiply it. So we're going to multiply that by 5, and then that answer goes under the next coefficient. So 4 times 5 is 20, and then you are going to add down, and you are going to repeat this process over and over again until you are out of numbers. So that is going to be 17. 4 times 17 is 68, and 68 plus 6 is 74. And 4 times 74 is 296. -1 plus 296 is 295. And then 4 times 295 is 1180. And then 1180 plus 12 is 1195. Now, I like to put this last number in the box. This is what we call your remainder. So just like when we used to divide when we were kids, you would have a remainder. So the answer to my problem is, oh, I forgot something. Let me back that up before we do that. Now, how to read this answer. This is your constant. This is your x, this is your x squared, and this is your x cubed, and you keep going up until you're out of room. So for my solution, I have 5x cubed plus 17x squared plus 74x plus 295, and then we can do one of two things. We can just say remainder of 1195, or we could say the actual proper math way to say this, or one of the other ones is plus 1195 over x minus 4, where x can't equal 4. Either of those is correct. If you are moving on in math, this is the one you're going to need more of. You're staying here. If this is your last class and you don't have to move on, then it's not going to be such a big deal. Okay, so the next question is, what if it's not? The divisor is not in x minus c form. Well, that's really a couple of things. Either it's not going to be possible via synthetic division, so you have to go back to the long division you learned prior, or we could potentially manipulate it. So in this example, we have x to the fourth minus 3x cubed minus 36x squared plus 68x plus 240, all divided by x squared minus 4x minus 12. So that's obviously the denominator is not in x minus c form, but can it be factored? Well, actually, it can. So you're really doing minus 3x cubed minus 36x squared plus 68x plus 240. And then this factors into x minus 6 and x plus 2. So now, instead of just doing synthetic once, we're going to do it twice. So I'm going to set this up as 6 is on my shelf. And then I'm going to do my coefficients, and I go 4, 3, ooh, I did something funky there. I go 4, 3, 2, 1, none. So there is no, there's no placeholder in this. So I'm going to do 1, negative 3, negative 36, 68, and 240. And I'm going to bring down the 1, and I get, so 6 times 1 is 6. Add down, and I get negative 3 plus 6 is 3. 6 times 3 is 18. Negative 36 plus 18 is negative 18. 6 times negative 18 is a negative 108. 68 minus 108 is negative 40. 6 times negative 40 is negative 240. And so I get 0 here. And then I am just going to take those coefficients and repeat the process with the negative 2 out in front. And so then I'm going to bring down the 1. Negative 2 times 1 is negative 2. 3 times negative 2 is 1. Negative 2 times 1, is negative 2. Negative 2 plus negative 18 is negative 20. Negative 2 times negative 20 is a positive 40. So my solution, and I'm going to go in and remember, this is your constant. This is your x, and this is your x squared. So my solution to this whole problem is x squared plus x minus 20. And that's how you're going to work one of those problems. Okay, so that is all we're going to do for the practice of synthetic division. However, everything that we do after this involves synthetic division, so there will be a lot more examples of it. So now we're going to pick up on remainder theorem. Okay, remainder theorem says if f of x is a polynomial and, let me scooch up, c is a number, then f of c is equal to the remainder of f of x divided by x minus c. Okay, again, we are going to use synthetic division. You can also do this a couple of different ways, but because of the way we're doing things, we are going to use, and we don't have a calculator. This is actually faster since you are not going to have a graphing calculator on this test. So, for example, we are going to find f of 3 if f of x is equal to x to the 4th plus 3x cubed minus 2x squared plus x minus 10. So instead of setting the factor equal to 0, it's already done for us. We're just going to put 3 on our shelf. That's all we're going to do. And then I'm guessing our Wi-Fi is out at the moment. So I'm going to do 1, 3, negative 2, 1, negative 10. And then I'm going to bring down the 1. 3 times 1 is 3. Put that on the shelf. Up above the shelf. 3 times 3 is 6. 3 times 6 is 18. Goes under the negative 2. Negative 2 plus 18 is 16. 3 times 16 is 48. 48 plus 1 is 49. 3 times 49 is 147. And 147 plus negative 10 is 137. Your remainder, is your answer. So your remainder is your solution. So you'll say f of 3 is equal to 137. In other words, what this is saying is that on this function, there is a point that is 337. That is what all of that is saying. The next thing we need to talk about is factor theorem. Sometimes, well, No, not yet. Hold that thought. So, if f of x is a polynomial, and the remainder of the polynomial, just like we found before, sorry, let me, not remainder of the polynomial, scratch that. The remainder of, scratch the b too, sorry, of f of x divided by x minus c is equal to 0. Then x minus c is a factor of f of x. So we are leading into determining if it's a factor or not, and then essentially going into how to determine multiple factors from one. So let's start with this first example. Determine if x minus 3 is a factor of f of x is equal to x cubed plus 6x squared plus 11x plus 6. If so, write it in factored form. Okay, so in this case, we want to see if this is a factor. So on my shelf is going to go -3. Or no, not -3, sorry, +3. And then I'm going to look at my polynomial. We go from cubed to squared to 1 to none. So that is going to be 1, 6, 11, and 6. I'm going to bring down that 1. 3 times 1 is 3. Add down. 6 plus 3 is 9. Oh, that should have been an x plus 3, y'all. Let's back that up really quick because this isn't going to work. X plus 3, so that is a negative. I apologize. That is a -3 there. So that makes this negative, and 6 plus -3 is 3. -3 times 3 is 9. -9, sorry. Don't drop your negatives. 11 minus 9 is 2. -3 times 2 is -6, and that would be 0. So, yes, it's a factor. Now, remember, this is your constant. This is your x, and this is your x squared. This is also a factor now. So when I go to write this up, I'm going to say, okay, well, I have f of x is equal to x plus 3, and then we have x squared plus 3x plus 2. Can I factor this portion further? Yes, I can. I can say, okay, we're going to do x plus 3, and then we're going to do x plus 1, and x plus 2 because the factors of 2 or that multiply to 2 and add to 3 are 1 and 2. And then that is all you need to do for factor theorem. We're going to do more talk on factor theorem in just a moment. Okay. Rational root theorem. Sometimes, oops, there's an L there. Sometimes we give you a problem and say, hey, graph this, and it's a polynomial and it hasn't been factored out. Well, how are you going to do that? That's what rational root theorem allows you to do. It allows you to find possible rational roots that could be zeros of your polynomial. We start with these letters, Q, and Q represents all integers, all integer factors of the leading coefficient. And then P is all integer factors of the constant. And then to find all possible roots, you are going to do plus or minus P divided by Q. And that will find all possible rational roots of a polynomial. Okay, so for example, we're just going to jump right in. We're going to start with finding rational roots. So we're going to list all possible rational zeros of the following. And we are going to do f of x is equal to 2x to the fourth minus 3x cubed plus 7x squared minus 5x minus 8. Okay, so with that, I am going to say, okay, P is 8, and I'm not going to worry about the sign because we will deal with that later. And Q is just the leading coefficient, so that is 2. So for P, since it's 8, our integer factors are plus or minus 1, 2, 4, and 8. Those are all numbers that can divide into 8 evenly. And then Q, same thing. It is 2, so that is equal to plus or minus 1 and 2. So we are going to use this piece and this piece to do our problem. So now I am going to do P divided by Q. And I'm going to do this the long way first. And so remember, you're going to start with P. So I'm going to do P1 divided by 1. And then I'm going to do 1 divided by 2 because it has to be by every possible combination. 2 divided by 1. 2 divided by 2. 4 divided by 1. 4 divided by 2. 8 divided by 1. 8 divided by 2. Now again, as you get faster, you don't need this step. Then I am going to simplify that and only write the ones that aren't duplicates. So we're start with 1 divided by 1 is 1. 1 divided by 2 is a half. 2 divided by 1 is 2. 2 divided by 2 is 1. I've already got that written down, so I don't need that. 4 divided by 1 is 4. 4 divided by 2 is 2. Already have it. 8 divided by 1 is 8. And 8 divided by 2 is 4. Already have it. So these right here, the positive and negative, 2, 3, 4, 5, these 5 roots, both positive and negative, are possible zeros to this problem. So here are all your possible ones you can do. The next part of the next example says find all possible rational roots then find all zeros. Okay, so this is kind of, your homework is like this, where we just give you an equation and say graph it. And you're like, but I don't know where to start without my, and remember, you won't have your calculator. So we're going to say, okay, we're going to start with x to the 4th plus 4x cubed minus 12x minus 9. So we're going to start with the rational root theorem to give us a place to start. So P is 9. So all my roots for 9 are going to be 1, 3, or all my values, integers for P is 1, 3, and 9. Q is just 1, so it's just 1. So P divided by Q is plus or minus 1, 3, and 9. Okay. Please remember all zeros have a y equal to 0. So what that's saying, or what that's reminding you of, is if you do something like factor theorem or remainder theorem, you want a remainder a remainder to be 0. That is what that is bringing up. When you do rational root theorem, there is this rule that if you substitute in 1, because 1 is easy, in anything, or 1 to any power is 1, you don't have to worry about signs. If you add up the coefficients, because 1 to any power is 1, and a number times 1 is 1, or not 1, the number, then you can test that out, and that would be always my first test. And really what I'm realizing it is 1 plus 4 is 5, minus 12 is 7, and then you're going to subtract more. Basically, this is not going to be 0. So in other words, not a factor. Okay. And I would always test this first. And then you could do -1 and see if it would work. Because that's just alternating based off a sign. So let's see, that would be -1 to the 4th would be positive, so that would be 1. That would make this -4. That would make that plus 12, and that would keep that at -9. 12 plus 1 is 13, and -9 and 4, so this would be 0. So -1 would work. So let's put that on our shelf. 1, 2. After those two, everything else has to be tested just using synthetic division. So also note you do have on here a placeholder. So I'm going to put the 1 for the fourth, 4 for the cubed. You're missing your squared term, so that gets a 0. Negative 12 for your linear term, and negative 9 for your constant. Put our shelf. Bring down the 1. Negative 1 times 1 is negative 1. At 4 minus 1 is 3. Negative 1 times 3 is negative 3. 0 plus negative 3 is negative 3. Negative 1 times negative 3 is 3. Negative 12 plus 3 is negative 9. Negative 1 times negative 9 is 9. 0. So yes, it worked. It is a factor and a 0, so it's both. Oh my gosh, I can't change colors. This is a factor and a 0. Okay, it's both. So then we're going to start working on our factoring completely. So I'm going to come up here and I'm going to say, okay, f of x is equal to x plus 1 times x to the, I don't know. That's my constant. That's my x squared, x cubed. Okay, so that's going to be x cubed plus 3x squared minus 3x minus 9. I'm going to see if I can group these. And you know what? Based off of looking at it, it looks like it's a pretty good grouping. So I'm going to bring that down to this group here. And we're going to do this. We're going to say, okay, that out of the first two, x squared factors out and leaves me with x plus 3. Minus 3 factors out and leaves me with x plus 3. Those x plus 3s are the same, so that is one factor. So we have the original factor of x plus 1, x plus 3, and then what's left over, that x squared minus 3. And now we're going to do our zeros. X is equal to negative 1, negative 3, and then plus or minus the square root of 3. And then you would continue on and you would do your y-intercept and you would use your multiplicity and you would factor, or not factor, but then you would graph it. That is what is expected of you on your homework, is to do all of that. Please, 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 this week, if you don't understand, go to tutorials.